In this video, you will see all the real mechanical engineering design steps involved in building a prototype Mars rover, including mathematical calculations, ANSYS simulations, CAD design, and the complete failure analysis and improvement process. This is my final year project, featuring a robotic arm and drilling system inspired by the actual NASA Mars rovers. The rover is operated through the internet, allowing it to be controlled from anywhere in the world. Let's move toward its design. I created a CAD model of our rover in SolidWorks. It is designed similar to the Mars rover. First, I made some 2D drawing in AutoCAD and then made the 3D model accordingly. This rover has a rocker bogie mechanism with 6 wheels. In the rocker bogie mechanism, all 6 wheels stay in contact with the ground all the time. It has a sample collecting robotic arm with 4 servo motors for movement and 2 DC motors for drilling. There is also a camera mounted on the rover which can rotate clockwise and anti-clockwise. One important thing in its design consideration is how much torque is required to rotate the tires. We have the torque formula T or F. Two forces act on the rover, the gravitational force and the force against gravity while moving on a slope. By putting the values, the required motor torque to rotate tires is 2.25 Newton meter. I also performed some tests on ANSYS workbench to check its feasibility. The first test was on the chassis of the rover. The total force applied on the chassis is around 50 Newton, and since we are making it with stainless steel, it is within its bearable range. Let's move to the design of the robotic arm. We need to find how much torque is required to lift the drill box. The robotic arm is 0.6 meters long and the drill box weight is around 160 kilos. By plugging the values into the formula, we get the required torque, which is 1.15 Newton meter. Second test was on the robotic arm, where maximum load was applied on the second rod of the arm and it was also in its bearable range. We have successfully completed the rover design. Now it's time to 3D print all of its parts. All the parts were sliced in Cura software and then 3D printed. It takes days to complete. Then we went to Lahore to buy all the required components. We buy everything according to our calculation. We also visited some famous universities like UET. Also, we enjoyed some Qawwali night here. Now it's time to assemble the project. First, we joined 2 sections of the body together and then made chassis of the rover, since there were some plastic connectors in our chassis which starts failing in loading conditions. We decided to make it by steel. We went to the workshop and made it using stainless steel. It took some days to complete and then fixed the body on the chassis. After that, we fixed the robotic arm on the chassis. Now it's time to move to wiring. I created some wiring schematics in KiCad software. Here we have the wiring diagram of the robotic arm, which has 4 servo motors and 2 DC motors for drilling. We are using Arduino Mega and ESP32. By using ESP, we can control the rover from any part of the world. I also created some wiring diagrams in Tinkercad, such as the wiring for the 6-wheel motors. I wired the rover according to those schematics. Now it's time to program the rover. I wrote the code using AI tools like ChatGPT and then changed the code according to my design. I uploaded the code using Arduino IDE software. After uploading, I noticed sometimes robotic arms start moving very fast or even breaking. So I did some alterations in the code while physically testing, like adjusting angles of the robotic arm, and at the end, arm working smoothly. Now we were done with our project. Now it's time to test. We went to the desert to test our project. In our control panel, we have 9 buttons. 7 buttons are used for controlling the rover and the remaining 2 buttons will be used for future upgrades. The buttons are named forward, backward, camera left, camera right, sample collect, etc. By pressing the forward button, the rover starts moving forward. And the same for backward. By pressing the sample collect button, it starts collecting samples. And by pressing camera left and camera right, the camera rotates accordingly. This is the real camera recording of our rover. We also presented our project in the recent exhibition held at the university, and we are also planning to exhibit our project in the upcoming exhibitions across Pakistan. It is a research project and can be used for many geological purposes. This rover helped me learn many softwares including AutoCAD, SolidWorks, ANSYS Workbench, Cura, KiCad, Tinkercad, Arduino IDE, and also improved my critical thinking skills. I also published a complete research paper on this project. You can check it out. Thanks for watching.